Hello to everyone and welcome to the YouTube channel School for All. This is tutorial number 19 of our C programming training. In this tutorial, we are going to study the while loop. Now, in the previous tutorial, we did everything concerning the for loop. I told you that we are going to solve more questions. Let us finish with the while loop and the do while loop first. Now, what's the difference between the while loop and the for loop? I think I said that in my previous tutorial. The while loop is used when the number of repetition is unknown in advance, whereas the for loop is used when the number of repetition is known in advance. So it's just the reverse, in fact. So I think the definition here, the while loop is used when the number of repetition is not known in advance, or either you say it's unknown in advance. It depends on you, but it depends on a condition. So this one is very clear. Now, you realize something with the while loop. So I want us to cover the while loop first. Then, when I will be doing do while loop with you people, we are going to compare now while loop and do while loop, because we have different type of question in the exam. Take note. Either they ask you to compare the while loop and the for loop, or either they ask you to compare the do while loop and the while loop. Take note of things like that. Now, we are under while loop. So this is the syntax here. So in summary, what you're supposed to note also is that a while loop is just like a decomposed version of a for loop. Meaning what? In a for loop, you realize something. That here you're having for, then you have initialization, condition, incrementation or decrementation. It's the same thing with the while loop. Just like with the while loop, you're not having all these three statements in one bracket like this. No. With the while loop, the difference is that in bracket you have but your condition. This all. Now, the initialization phase here for the while loop is done but out of the while loop, meaning it's done before even starting your condition. Now the incrementation or decrementation is done but inside the while loop. So this is what you need to note. We are going to solve now a question. You'll see how things work. How is the while loop functioning? The while loop is testing a condition before executing a set of instructions. So this is exactly how it works. So a while loop, if they ask you to define in the exam, you say a while loop is a control structure that executes a set of instructions based on a condition. And you continue by saying that here the condition is tested first before executing the set of instruction, and it's the reverse of the do while loop. A do while loop is a control structure that executes a set of instruction at least once before testing a condition. This is exactly what you are seeing here. So that's even the difference between while and do while loop. In do while loop, you execute at least one time before testing a condition. I will give you a scenario where we use this type of thing. You understand it better. Now, whereas with the while loop, it's not possible like that. If you test your condition for the first time and it is false, you will never execute what is inside here. So you are seeing that with the while loop, there is a possibility of not executing what is in bracket. Whereas with the do while loop, it's not possible. With the do while loop, look here. You see, you execute first because you have the do before you have while under. Meaning that at least one time you execute this one. Example, print numbers from 1 to 5. So I want us to solve the same thing we did in the previous tutorial using for loop. So that this time we are doing that with the while loop. From there you understand how things work. So let me just open my dev C++. I open this. I create a new file, new source file. Now from here, remember good manners, you save it first. File, save as, desktop. I have a folder here called C programming. Okay, let me just call this while loop. Save as type, C source file. You save. Now you start writing. So remember that the basic structure of the program, hashtag include stdio.h. Basic structure in main. Okay, return 0. Now, so this is where everything starts. Now, how to write a program that displays integers from 1 to 5. Now, for you to write this type of program, let me just do something here. Okay, so that you'll be understanding what you are doing. Now, the idea here is clear. I'm trying to display integers number from 1 to 5, and you are using a while loop. And you know very well that this is the structure of a while loop here. While in bracket you write what? Condition. Before now you come and execute something inside, then you close. Now, and each time you are working with a loop, I think everybody master this notion that when you test a condition and it is true, you come and execute this. After executing this, you will never go out. You come back and test again. You can only go out when the condition is false, because this is one mistake students are doing. Meaning what? They will come and test condition one time, then they enter here. After executing this, they go out directly. How manage? Never try to do something like that with loops. Loop is repetition control structure. So if you test your condition one time, it is true, do what you are supposed to do and come back and test your condition. And if your condition is always true forever, your loop will just turn forever like that. So I think you're getting the point. Now, when you're having this type of question, this is how you're reading, you ask yourself that, okay, I want to display 1, 2, 3, 4, 5. You think that, okay, my first value is starting with 1. But ask yourself, what is happening to this 1 to have the second number? You realize that you are adding 1 to the previous one. Ask yourself again, what are you doing to the second number now to have the third one? You are still adding 1 and so on and so forth. So you are realizing that, okay, if I'm having a variable called a, and that a is having an initial value of 1, for me to have the next value, I'm just supposed to do a equals to a plus 1, so that the previous value of a is what? 1. 1 plus 1. The answer is what? The answer is 2. It means that the new value of a is what? Is 2. And you are seeing that the new value of a, so you need to re-execute this same instruction to have something like a equals to the previous value of a is what here now? 2. 2 plus 1 is giving what? 3. And after having this 3, you need to re-execute this same instruction again to have what? 4 and so on and so forth. So you are seeing that this instruction here should be inside what? Should be inside, let me use a red pen. You see that this instruction here should be inside what? Should be inside the while loop, because it's inside the loop that we can execute an instruction what? A certain number of times. So this is how we are raising when we are writing a program. Don't think that you are just starting like that without even thinking the way we'll be doing the code. No, you're raising. Meaning, as I'm doing this program like this, another person can do it another way. It depends how you are thinking for your program. So this is exactly what happens here. And it's just a variable. You can decide that, okay, you use a variable called I. So if your problem there is no problem. Now, since this instruction here, a equals to a plus 1, is written inside my while loop, now you ask yourself, okay, something inside the while loop is something that must be executed repeatedly. But now, what's the condition that must stop this execution? Because you cannot execute this instruction forever. No. By the moment you have something like a equals to 4 plus 1, which is what? 5. You don't want to re-execute again this instruction, because re-executing this instruction, you have now what? A equals to 5 plus 1, which is 6. And you are not counting up to 6. So you are saying that you need a condition that when you have exactly the last number that you are waiting, it should go out of the loop without re-executing that. And how to have something like that? It's very easy. As I was telling you, in this case, if you are initializing your a to 1, it means that your condition here must be something like a less than or equals to 5. So that each time when a increment, you come and test if a is less or equals to 5. Meaning that by the moment a will move to something like 6, you come and test. Is 6 less than or equals to 5? No, and you don't display the 6. So I see that this is the general idea. So let us do it like that, and if there's any problem, we are going to correct it together, because my aim is not just to how can I say it, to give a code like that. No, I want us to raise it and we do it at once together, so that if there's a mistake, we should correct it also together. Because if I just write a code, you people think that, okay, it's easy for the teacher, but for me it's not easy. So let me just put myself in as a student and work. Okay, so I come now to my dev C. Here I'm going to say int a. Okay, now you come here, you say a equals to what? 1. It's what we said, right? Now you come here and you say y. Okay, y what? You say y a less than or equals to 5. I open this, and what are you doing inside? You are doing a equals to a plus 1. Hope you are together. And after doing a equals to a plus 1, what are you doing? You must print the result of a, right? Print f like this. Yeah, you say you do something like percentage z. You put your slash n. You put your comma, and you put what? A. You put your semicolon. Now, if I run this program, you realize that there's a problem. Let me just run the code, because generally from result also we can see how to modify the program. Let me just run it. You see that here I'm having what? I'm having 2 to 6. 2, 3, 4, 5, 6. Problem. The first problem here is what? That I'm not having 1. And the second problem is that I'm supposed to end at 5, not 6. Okay, from here you will get the problem. The first problem here is that A is starting at 1, you are testing, you come and test, is 1 less than or equals to 5? Yes. But you realize that inside the loop, because if the condition is so, you enter. When you enter now, what are you doing here? You are doing A equals to A plus 1. So you are seeing that here the new value of A moves to what? 2, because you are doing 1 plus 1 plus 1, since the previous value here is 1. And that's why the first A being printed here is what? It's 2. So to avoid this mistake, remove this here and put it before this instruction here, in such a way that, okay, when A is equals to 1, you will test, is 1 less than or equals to 5? Yes, you print the 1 first before incrementing the value. Good. Now, let us stop here first and execute the code. Now, and why am I doing this? I'm doing this to tell you that generally when we are writing a program, we must dry run that program. You must manually execute it yourself. Because some students think that the computer is just a machine doing everything for you. No, remember that you are the one giving instruction. If you give wrong instruction, you have wrong result. So always have your paper, I don't know, a notebook, something like that. You take note of what you are doing. You dry run it inside your notebook. That's why in the exam, even when you are writing the paper 3 section, you still have papers where you can write and do your thing. It's not for nothing. So I come here, I execute this program. Now you see that here it's going to start with 1 normally and it's ending at what? At 5. Now why is it that it's ending at 5? It's clear now. Because when A here moves to 5, you are going to tell, is 5 less than or equals to 5? Yes, you enter and display this, right? Now after displaying this, A here moves to what? 5 plus 1, which is 6. Just that when you are coming back with a 6, you are testing, is 6 less or equals to 5? No. That is why you don't enter again. Take note of things like that. And it's all the program here. So you are seeing that here, this is just one way of doing it. This is one way of doing it. This is my final result. It's all. Now let me just modify this program. Another person can decide to use 2 variables. He can decide to use a variable, let me just say command here, a variable called count. A variable that will help you to count the number of times you are printing your A. So in this case, what happened is I'm going to initialize A to 1 normally, but I will initialize also count to 1. Just like this time I'm no more using A to test condition or to count something. No, I'm no more doing that. What happens here is you come and say, okay, A equals to 1, count equals to 1, and here you are testing if count is less than or equals to 5. Now after that, if it's the case, what are you doing? You display your A, you increment your A, and you do also count equals to count plus 1. Now, so the only difference here is what? That the A that you are incrementing here is just for the printing. The A is no more here to test condition or things like that. No, you have now another variable used to count the number of times you are printing. Like your count start at 1, is count less than or equals to this? Yes. You come and you display your thing. Then the next thing here, you do what? Count increment to 1, meaning that you go now for the second time and so on and so forth. So if I execute this program, I'm going to have the same result. Another person can decide that, okay, my count start at 0. If your count start at 0, here you put what? Strictly less than, and here you put yeah, I think it's all. If you execute this program, the same result. So there are different way of writing this type of code. So let me just end here for this tutorial. You have time to solve more questions. You have time to solve more. The idea is first of all to introduce how they work and so on and so forth. So if you have enjoyed the tutorial, make sure you leave a positive comment, like the video. Any misunderstanding, if you're not getting something well, or if you're doubting, leave a comment. I will reply to you, because my aim is that everybody looking this video must be 100% okay. Don't come and look this video, you have problem, you keep it for you. There is your own problem. Okay, see you, ciao.